For centuries, native people used a natural chain of lakes and rivers through Nova Scotia as a transportation route. The Mi'kmaq, who lived, hunted, and fished along its shores, called it Shubenacadie. In September 1767, Captain William Owen of the Royal Navy arrived in the new colony of Halifax. In the company of some friends and an Acadian guide, he set off to explore inland Nova Scotia by boat. It took them a full day to travel the 6 kilometers from Dartmouth Creek to Lake Charles. Captain Owen, one of the first Europeans to deliberately travel this waterway, confirmed the existence of a navigable route from Dartmouth to the Bay of Fundy. If European vessels were to sail this waterway, changes were needed. In time, this would become the Shubenacadie Canal. Canals are artificial waterways which permit boats to sail directly between 2 points, often over hills and through valleys. Some canals, like the Suez Canal in Egypt, are dug between places where water has never before flowed. Others, such as the Rideau Canal in Ontario and the Shubenacadie Canal in Nova Scotia, were built to facilitate navigation of vessels along existing rivers and lakes. Most of Canada's canals are of this type. Canals look like a long, narrow trench filled with water, and they are, but they are much, much more. Canals demonstrate an elegant simplicity of operation. They are special because people must think, plan, and work hard to create them. Canals change landscapes, not to mention the lives of those who build, use, and live along them. This is how canals work. Running downhill, water creates rapids and waterfalls. Only light boats, like canoes, can safely pass such obstructions. Large boats with heavy cargoes must have deep and level water for safe sailing. Canals make water level by creating what looks like a giant staircase. A boat moves along to the first step or level to where the water flows downhill. To get down to the next level, the boat enters a lock, a large chamber in the waterway with huge gates at both ends. Then, the lockkeeper closes the gate behind the boat, isolating it. The lockkeeper opens a valve, letting water out of the lock, and the boat floats gently straight down. When the water inside and outside the lock are at the same level, water pressure on the gates is eliminated. The gates are then opened, and the boat can travel along to the next step of its journey. To go uphill, the process is reversed. Locks are simple to operate, but complicated to build. Their walls and gates need to be massive to take the great pressure exerted upon them by tons of water. The valves and gates must function easily without letting too much water through. Back in 1767, when Captain Owen made his Nova Scotian trip, canal development was just beginning. Among the first canal builders were the Duke of Bridgewater, the potter Josiah Wedgwood, and Thomas Telford, one of the greatest engineers of 18th century England. Canals proved to be the answer for shipping the many products of the early Industrial Revolution. Thousands of kilometers of canals were built between cities and seaports in Britain and Europe. Canal laborers, called navigators or navvies, traveled from worksite to worksite. Industry grew and commerce flourished along these waterways. Not all were financially successful, but canals symbolized the optimism of their age. As canals grew in Britain, her new colony, Nova Scotia, was also growing. With the outbreak of the War of 1812, Nova Scotia became worried about an invasion from the United States. A canal along the Mi'kmaq route offered British troops fast access to the Fundy shore to protect against invaders. A survey was made, and it proposed building a canal between Fort Sackville on Bedford Basin and Lake William near today's village of Waverly. From there, boats could travel to the Shubenacadie River and the Bay of Fundy. However, the war ended in a British victory. The threat of attack passed, and so did the need for a canal. It was some years later when a group of prominent merchants and government officials reviewed the idea for commerce and formed the Shubenacadie Canal Company. They invited Francis Hall, an English engineer who had worked with Thomas Telford, to survey a canal between Halifax Harbor and the Bay of Fundy. Hall proposed the same route taken by Captain Owen over 50 years earlier. In July 1826, the Canal Company began work at Port Wallace, named for Michael Wallace, president of the company and one of Nova Scotia's most influential citizens. There was great ceremony. Lord Dalhousie, Governor-General of Canada, and Sir James Kempt, Lieutenant Governor of Nova Scotia, broke the first ground for the canal. Watching from the sidelines were hundreds of canal navvies, mostly Irish, who, with their families, had come to Nova Scotia to work. As soon as the elaborate pageant was over, they moved in and set to work. A year later, stonemasons arrived from Scotland, where they had been working on the Great Caledonian Canal. For 5 years, Irish and Scots picked and blasted their way through solid bedrock along the canal route, cutting granite blocks and cementing them into place. Construction costs rose as severe Canadian winters broke down their stonework. In 1831, the project stopped. But the stonecutters and navvies left their mark. Today at Port Wallace, visitors can see their locks, the deep cut they dug with such diligent toil, and the remains of their stone houses. The houses, stone walls set into embankments, closely resemble the architecture of ancient rural Ireland. Today, they are unique among Nova Scotia's heritage sites. The story of the Shubenacadie Canal might have ended there in 1831, were it not for the commitment of the company treasurer, Charles Rufus Fairbanks, who kept the idea of the waterway alive. Years later, in 1853, his son, Charles William Fairbanks, was engaged by a new company to complete the Shubenacadie Canal. The younger Fairbanks had studied hydraulic engineering in England with Sir John McNeill, who, like Francis Hall, had been a disciple of Thomas Telford. Fairbanks was well aware of English hydraulic engineering, but also had an eye for new developments in the U.S., like the Morris Canal in New Jersey. Using designs from the Morris Canal, Fairbanks rebuilt the lock walls using less expensive materials than the solid stone of English locks. He made the locks of rubble stone, cemented together, then lined with wooden planks. Fairbanks also replaced a number of old locks with inclined planes, or marine railways, which, although not an American invention, had been applied with success on the Morris Canal. These railways, operated by water power, could raise and lower boats quicker and cheaper than a series of several locks. By 1856, parts of the new canal were operating between Grand Lake, Waverly, Portobello, and Dartmouth. In 1861, with the completion of the Dartmouth Inclined Plane and 4 locks in the Shubenacadie River, the steam vessel Avery took the first round trip from Dartmouth to Maitland. Vegetables, coal, bricks, pottery, lumber, and the very equipment used to build the railway that eventually put the canal out of business All these were shipped on the Shubenacadie Canal. While business was steady, it was not brisk. Finally, the new railway replaced its drawbridges over the canal with fixed spans, bridges so low canal boats could not pass under them. In 1870, the canal company closed. But that was not the end of the waterway. Today, through historical research, archaeology, and engineering, the Shubenacadie Canal Commission is working to preserve the story of the canal and its natural environment. This beautiful and historic waterway is today a recreational resource we invite everyone to enjoy.